In previous videos, the discrete notion of a continuous probability function was used to create the idea of a continuous probability function. Also, the discrete notion of a probability density function was expanded to create the continuous probability function. Now we turn our attention to the cumulative distribution function, or CDF. This is actually going to be one of the easier changes. Recall that the CDF, Fy of y, or Fx of x, is defined as the probability that your random variable is less than or equal to y. This is identical to the definition in the discrete setting. The only change is that to compute this, instead of adding up all the values before y, we integrate all the values before y. So consider the following example. Y has PDF given in two parts, as you see here. If I want to compute the CDF value at a half, I need to find the probability that the random variable is less than or equal to a half. That means integrating from negative infinity to 1/2. However, the PDF came in multiple parts. On the screen you see 2 parts, but actually there are 5 of them. There are regions here that were omitted because they had probability 0. In particular, from negative infinity to -2, the probability, or PDF, was 0. From -2 to -1, the PDF was a half. From -1 to 0, nothing was stated, so that was a 0. 0 to 1 was a y, and 1 to infinity was 0. So in order to integrate from negative infinity to a half, you're going to be integrating across many of these different values. In particular, it covers everything up to the point y equals a half. Working our way from the bottom up, from negative infinity to -2, there was 0. From -2 to -1, the PDF was a half. -1 to 0 was again 0. And then finish off by integrating up to a half. Why a half instead of 1? Because the question asked us to find the probability of being less than or equal to half. Be careful about this. A common error is for students to find the right piece, in this case the 0 to 1, and to integrate over the entire region. Here we want to go to a half only. Integrating 0 gives me 0, so the red pieces drop out easily. And the blue pieces are standard polynomial integrals. Plug in the limits on the integral, do a little arithmetic, and we find that the CDF value at a half is 5/8. That means that when this random variable is picked, there is a 62.5% chance that it will be less than or equal to a half. Let's look at this one more time. Just to make things a little simpler, notice that the pieces that I had put in red didn't matter. So the original PDF only included 2 intervals, and actually those are the only intervals you need to look at. So I could draw the same number line, mark out only the intervals that were non-zero, and revisit my integral. So working from negative infinity to a half, I cover the entirety of the left interval, so -2 to 1 of a half, and on the right interval, I cover from 0 to a half.